The broadcast is now starting. All attendees are in listen-only mode.
Thank you for joining today's webinar, Navigating the Ecosystem, Getting Started with Thread Group to Develop Your IoT Solution for the Smart Home. Please note this webinar is being recorded and will be available on the Thread Group website for future reference. Today, our panelists will cover an overview of Thread and the key steps to take in creating a Thread solution. Following the presentation, there will be some time to address questions related to the webinar content. Please note all webinar attendees are on mute. If you have a question for our panelists, please use the question pane on the right-hand side of your screen. Questions will be read and addressed by our speakers at the end of the presentation. Questions will only be seen by the webinar organizer and speakers. If your question is not addressed in the Q&A session, someone from Thread Group will follow up with you directly. With that, I'm happy to introduce today's speakers. Grant Erickson, President for Thread Group and Principal Software Engineer for NAS, and Sujata Naidig, Vice President of Marketing for Thread Group and NCU Global Marketing Manager for Nxp. At this time, I will turn it over to Grant to provide you with an overview of Thread.
Thank you for the introduction. It's my pleasure to talk to you today about Thread, first providing more insight to the question, what is Thread? The Thread was designed with one and only one goal in mind, to create the best way to connect and control products in the home. With that goal in mind, Thread offers several features and benefits worth considering as we move through this presentation today. Built-in network layer security, low power, easy to set up and use, an open IPv6-based protocol, and a robust mesh network. So why did we choose a mesh architecture for Thread? We chose a mesh architecture for Thread because it's self-healing with no single point of failure. It does not require extra dedicated network hardware such as repeaters. It naturally overcomes wireless interference. It supports low-power, sleepy nodes, and it's reliable enough for critical devices and applications in the connected home. Thread delivers a legacy-free, secure, wireless mesh network for connected products in the home by situating itself between widely available standard IEEE 802.15.4-2006 2.4 gigahertz silicon and one of many possible internet-based application layer protocols by using an IPv6 adaptation layer provided by a technology called 6LoWPAN. Thread also defines an easy-to-use and secure out-of-box commissioning architecture and protocol along with strong, always-on default network layer security. Thread's architecture supports up to or in excess of 250 plus products per network with very low power operation where it's needed. In the following slides, I'll provide you some insight as to why we felt Thread was the right fit for the market. With Thread, we found the need for a new wireless network, as we considered some requirements including low power, resiliency, internet protocol-based, open, secure and user-friendly, fast time to market leveraging existing radio silicon, and consumer and home ready. And so as we thought about these requirements, we realized that we were entering a new era of connected products, products that are part of the Internet of Things. We wanted to use and leverage an existing mesh protocol, but we found none fit the requirements we had well enough. And as we looked around and asked other companies, we found that they had the same concerns and came to the same conclusions. And so together with this group of companies, we created Thread, a new wireless mesh network technology built on and leveraging existing open standards using established internet protocols. And it's important with Thread that we really are emphasizing the internet and Internet of Things because we really believe that the internet is a key ingredient of these products and of these protocols. And historically, constrained embedded devices have used specialized proprietary communication protocols that are of course low power and low bandwidth, but they are completely fit for purpose from top to the bottom. By contrast, the internet and the larger World Wide Web are built on a layered stack of open standards where each layer is independent and not necessarily tied to the specific application at the layer below or at the layer above it. And because of this flexibility and this ability to mix and match protocols at each layer for the suitability of the application at hand, this is one of the reasons why the internet has become so pervasive and flexible. And we hope that same level of flexibility imbues a level of similar success with Thread. And so now we have the technology that uses internet standards combined and coupled with constrained embedded devices to deliver applications for the Internet of Things that can run anywhere, whether the cloud, the controller, the router, or endpoint devices. And of course, reinforcing this point, at the end of the day, it's best to think of Thread as IP, providing a unified convergence layer for all different types of underlying network technologies across the home that allow you to reuse software stacks, reuse application protocols, enabling device to device, device to the cloud, device to mobile, and one-to-many or one-to-one communication among these different interaction models. And just like the internet at large, there's support for many different application layers, all running simultaneously, concurrently, over Thread's IPv6 unified convergence layer for the home. And today, when we think of Internet of Things and the Internet Protocol, it typically refers to large devices. These are mains-powered, fast networks, typically using Wi-Fi. We typically see JSON-based applications over HTTP, using TCP as a transport, typically using TLS as an underlying session security layer, and then, of course, riding over the traditional IPv4 or IPv6 Internet. But with Thread, we now take that same suite of applications and the possibility of those applications, and we bring it down to the world of small devices. And as a parallel, there are certainly more opportunities in different application layers, but you have something like CoAP, which is analogous to HTTP. Rather than using the connection-oriented TCP, we use UDP datagram transport. Rather than using TLS connection-oriented session security, we use datagram session security and DTLS. And then we use the 6LoWPAN layer to adapt Thread to an IPv6 network. And so the internet is now available in both large and small. So next up, I will hand it off to Sujata to tell you more about questions and considerations to make as you build out your Thread-based products.
Thank you, Grant. Yes, so I'm going to take over and talk to you about the focus of this webinar is to really talk to you about how do you go from your idea and create a Thread-enabled product and kind of talk you through some of these steps. So Grant gave a great explanation of what Thread is, why Thread was created, and so when we're starting to think about what type of products you want to create, these are some example target applications. So Thread was designed to connect all kinds of products in the home to work together in a cohesive mesh network. Products that are controlling different aspects of the home, whether it's appliances, home automation, like blinds, lighting, security systems, energy management, safety systems, climate control. Those are all just a few examples of the different types of devices that can benefit from being enabled by Thread and working on the same network so they can communicate to each other. Once you've identified the application you want to create, Many of these applications exist today, or products exist today, and the idea now is to add the connectivity of the smartness to it. And when you add connectivity to a device, the choice of the wireless technologies that you want to include is not a trivial decision and should be investigated thoroughly. Connected devices for the home environment have different use cases than what we're typically used to with traditional connected devices like phones. Devices in the home will be kept in the home for a lot longer without upgrading and replacing, and so you need to really take that into consideration as you decide on the connectivity choices you want to include. So some of these different considerations are listed here. The first one is the number of connectivity technologies that you want to implement in your product. How many technologies do you want? Is it just one, or do you want to support multiple? And this decision is really based on what your use case is. Is this product going to be a device that connects and communicates primarily through a smartphone? Is it something that's controlled through the cloud? Does it connect to multiple devices? What are all the different use cases that you're trying to adhere to with your product? And that will help you decide on which options to consider. And we'll talk a little bit on the next page about these various options, but some are Wi-Fi, Bluetooth Low Energy, and 802.15.4 with Thread or cellular. Another question or consideration to really think through is the time and effort to get to market. What is your market window? What are the resources you have available, whether they're part of your company or you have access through partnerships, and when do you need to get to market by? Another consideration is about your supply chain and the target cost for your device that you're creating. Very many times getting something from prototype to production is the hardest piece, and making sure you've selected the right components, and whether it's components or modules and certifications of, especially around the RF piece of it, that has a huge impact on meeting your requirements from a market window and resource perspective. The other thing here is the size and number of interoperable ecosystems for your product. So is this a standalone unit? Does it fit into a proprietary ecosystem? Does it fit into other ecosystems that are available? And I will discuss this more in a few slides. And then the value proposition. What is the value proposition that your company has built your success on, and how does this product fit into that? What experience are you delivering to your customer? What's the primary target? Is it energy savings? Is it the way that users interface with your device? Is it the experience that it provides? Really understanding and capturing that will help guide you through the process here also. And then again, I talked about it briefly, but the long-term support obligations, really understanding once this product is deployed and to your users, how do you support that in the long term? When we talk about wireless IoT standards and what you want to implement into your solution, people often talk about the fact that there are so many IoT standards out there, and how do you know which ones to use, and it's like the alphabet soup of IoT. So I wanted to quickly just categorize the different standards that are available for the IoT and doing wireless connectivity. The first thing is the connectivity layer. So that is the foundation that provides the interface on how devices connect wirelessly to each other, how they connect and how the network is managed, and that's the connectivity layer. And examples of this is Thread is a perfect example, but other examples are Wi-Fi, Zigbee Pro, and there are a multitude of others. The second category is when you're talking about an application layer. So the application layer is what runs on top of the connectivity layer. It provides the interoperability with other devices in the network or the cloud. Basically, it defines the language that these devices are talking to each other. And multiple application layers can run over multiple connectivity methods. And examples of a pure application layer are Allseen, IPSO, OCF, the Zigbee cluster library, and then there are a multitude of vertical industry alliances that provide application layers targeted for that specific industry. And the third category is providing the full stack technology where the connectivity layer is combined with the application layer for an end-to-end solution. Examples of this are Bluetooth, Zigbee 3.0, Z-Wave, and ULE. So on this slide, I have taken a stab at giving you kind of an array of different wireless technologies that are available. And again, you could decide to select one of these in your product or multiple options. And I'm not going to go in huge detail because there's a lot of information on this slide, but these will be available to you to look at afterwards. And what I really want to point out is, first of all, the different technologies that we have listed here. So you have Wi-Fi 802.11 BGNN, you have 802.11 AH, the new Halo that was announced earlier this year. You have Bluetooth Low Energy 4.x and then Bluetooth Low Energy Smart Mesh. And there's Zigbee 3.0, Z-Wave Plus, ULE, and of course Thread. And when you're looking at the various technologies that are available, some of the things that we recommend you look at and see how they fit into your application are listed along the side here. So the first thing is the range. What is the range required for your product? And then the topology. What type of network topology makes the most sense, whether it's star or mesh? The second thing here is bandwidth. What is the data that you're communicating? What are you transporting? Is it video, streaming video? Is it audio? Is it data? And what are the bandwidth required for each of those? And the various technologies here you can see have a wide range of bandwidth capabilities. So if you're trying to do video streaming, then something like Wi-Fi is definitely where you would start to look at, and something like Thread does not address that use case. But if you're trying to control devices and sending control data that requires low latency and low bandwidth, then Thread is an ideal solution. The third category is supporting IPv6. So Grant talked about the convergence of IPv, having IPv to provide that convergence of different technologies. So do you want the technologies embedded in your product to be supported on IPv6? The next thing here is open standard. Do you want an open standard or not? And then the application layer. Do you want a built-in single application layer, or do you want to be able to support multiple application layers? The next thing is we have taken an approach of looking at what are the different use cases for each of these technologies, and this information comes from the various alliances information. So you can see that they vary from on Wi-Fi with audio video equipment and main powered devices to Thread being mission critical IoT devices that are built for the home. So every single one of these technologies does have some very specific use cases that you need to consider and how that fits with the application and product that you're creating. Benefits of each technology are also listed here, whether it's about low power, high performance, what type of security is enabled. Those are the different types of attributes to look for and see which one of those is a benefit to your product and your application. And then availability, which of these technologies is available today, or when is it going to be available, and also is it available from multiple sources. So those are the different types of things you can look at to help you decide on which technologies you want to include in your device. So next you want to look at what kind of device are you building. Is it plugged in or is it battery operated? Is it always on or is it in a standby mode? What kind of user interface does it have? How frequently does it transmit or receive data? What kind of data is it generating or receiving? And what are the bandwidth requirements for that? And then to go into more detail about the user interface, how will your users interact with your device? Is it a passive device or is it active? Are you using a phone to control it, or an app or a web interface? Maybe it's physical buttons. It could be a combination of those or something completely different. Are you going to use your own app to control it, or do you want it to be part of a platform, a third-party app? Do you want other developers to be able to write apps to run on your device? What is the purpose of your device? Is it a mission critical? If the network goes down, does that have a catastrophic effect, or is it recoverable? What do you want users to experience as far as setting up the network? Is this a system where you'll have a professional installer, or is it something that you want consumers to be able to add onto the network or commission easily? Will this device be accessed remotely, or when the user is in the vicinity, or both? And will you have multiple users access the device at any time, or will it always be a single user? So those are some considerations to really go through in deciding how your product is going to interact with your targeted audience. And if you're at this point, you've already selected Thread as one of the technologies you want to implement. And when you decide that, you also need to look at what specific role is that product going to be in the Thread network. Is it going to be an end device? Is it going to be a router? Or is it going to be a border router? And the differences here is end devices are sleepy devices most of the time, battery operated, really low power. And so they are going to be able to stay in a Thread network in a sleep mode and only wake up when needed. A router is a device in the Thread network that is actually routing packets of information. And the border router is what translates from the Thread network to another network like Wi-Fi. And then this question here is about what ecosystems and devices add value. When you think about creating your product, we talked about it earlier, you know, what ecosystems do you want this to be part of? How do you get your product to provide more value to your customers, gain more traction, have that stickiness? Are there specific ecosystems that you want to participate in? So some examples are listed along the bottom here, and these are some open ecosystems, and then there's closed ecosystems. And why would you want to be part of an ecosystem? So if we look at Works with Nest, for example, maybe you're a company that is building door locks, and you don't want to build other components of the smart home, and you want to be able to interact with other companies' products. So with Works with Nest means your door lock can talk to your carbon monoxide detector or your thermostat, or your fan can talk to, if you're building a fan, it can talk to the thermostat. So that's what it means to be part of another ecosystem. There's also some closed ecosystems that are self-contained, like Wink. So understanding all the different options that are available to you for the different types of ecosystems and which ones are the ones that gain you the most benefit for your product is very critical in what you do next and how you take the product through the design and into the market. So step 2, now that you've defined your Thread product and have all of the outline of the requirements, one of the key things is the application layer. What do you want the user experience to be? So application layers, you know, Grant talked about it a little bit, but the Thread is a network and transport level stack. It does not encompass the application layer. You can see from this stack diagram on the right where Thread fits. The boxes outlined in orange defines what Thread is. It is the network and transport level that sits on top of a standard 802.15.4 MAC and PHY, and it includes the routing, running 6LoWPAN, and security and commissioning. The application is something that sits on top of that. Thread is application layer agnostic and can support multiple application layers. It can work with multiple transports also. So one of the big advantages with Thread is that because it's at the networking layer, you can have multiple application layers use the same Thread network. And that means that you might have different devices in the home that have different application layers, but those devices can still connect and route data through the mesh network to each other. So this is the reason why Thread does not include an application layer, but any IP-based application protocol can be adapted to run on top of Thread easily, as well as non-IP-based application protocols that would require some sort of adaptation. So here's some example application layers. We get asked often about why Thread doesn't include the application layer, so I gave you a little explanation of that. And you know, our members are made up of various different market segments and applications and different use cases and have different requirements for what the user experience is about. And Thread, we stay focused on making sure we're providing the best technology to connect the products. So here is a list of 4 different application layers that are examples: Zigbee, OCF, All-Seen, and Nest Weave. For Zigbee, it is a proven, that's the Zigbee cluster application library, and this is a proven and widely deployed application protocol that's been in the market and is being adapted by Zigbee to run over Thread networks, targeted for home automation and lighting applications. And again, the big benefit here is that developers can build a Thread-based solution and adding a field-proven technology to it from the application layer perspective. OCF is an open source application solution that's designed to enable developers to deliver interoperable products for the connected home. So with OCF, it spans multiple networking protocols and supports many different product types. The All-Seen Alliance has an open source application solution that is really designed and targeted for Linux-based systems in mobile devices as a primary use case. Again, the benefit here is to provide an open source framework that really promotes interoperability, no matter what the transport layer is. And then Nest Weave is an application layer that's specifically designed to connect products in the home that are part of the Works with Nest ecosystem. So it's more of a proprietary or not proprietary, closed system, but it's an application layer that enables that connectivity to, or that communication to different devices within the Works with Nest ecosystem. Use cases is targeted towards connected home products, and benefits is really for low latency, low powered devices, allowing devices to communicate to each other effectively and do it when an internet connection may not be available. With that being said, Thread also recognizes that our members are driving towards having complete solutions, and what we can do to enable that quick time to market or easier implementation is to work with other alliances in the industry through partnerships to provide a complete solution. Thread, again, supports multiple application layers, and we really want broad market adoption for application layers that align with our members' interests and growing Thread in the connected home market. So we have partnered with a couple of alliances to provide a more streamlined approach to delivering a combined solution. However, nothing prevents any other alliance that has an IP-based application layer from using Thread. The agreements we have in place today are with the Zigbee Alliance and with the Connected Lighting Alliance. And I'm going to go into a little more detail about the Zigbee Alliance and what that means from a partnership perspective with Thread. So Thread and Zigbee did announce about a year ago their intent to work together, and then at CES this year, Zigbee announced that they've made the decision to adapt Thread as their IP-based networking layer for Zigbee 3.0. So Zigbee Alliance is adapting their application layer, the Zigbee cluster application layer, to run over Thread networks. And what this gives is, again, it gives vendors and developers a very robust and well-known deployed solution that they can add on top of Thread, which gives them the IP-based capability and have interoperable devices. And through our liaison agreement, both organizations are working together to enable our members to be able to develop this solution more easily, to deploy their products and to certify their products more easily. And you'll start to get more information about this in the fourth quarter of this year. Okay, so now it's time to start developing and taking your product to market. So what can you do? What does Thread Group provide to help you with those efforts? Within Thread Group, there are many different types of companies represented. So when you're ready to get started on developing and designing your product, there's an array of options and resources you have available to you as a Thread member when you join Thread. The categories are listed here, and I will talk a little bit more detail and give examples for each one of these. But you have OEM product vendors, you have semiconductor suppliers, software stack suppliers, service providers, and RF module suppliers. So starting at the foundation, when you want to implement Thread, you need to select the silicon, that's the 802.15.4 radio, and there are many product companies today that have 802.15.4 radios that you can use, and there are more that are in development. On top of that, then you need a stack to run on the 15.4 silicon that implements Thread. Currently, there are 3 companies. These companies are the three of the 7 founding members of Thread Group. So ARM, Nxp, and Silicon Labs all have early versions or pre-certified Thread stacks with their chips that implement the radios. Please contact any one of these companies to get access to their Thread stacks and understand their solutions, their silicon platforms, and how that aligns with your application requirements. There will be more silicon and stack providers over time. And also, about a month ago, Nest announced an open source implementation of Thread that's been released by Nest to the GitHub. That's the Open Thread solution released by Nest. So these are all options that you have to consider when you're starting to select your components and the software that will actually implement Thread. And the silicon and the software stacks are pre-certified today only because certification has not been released. Once certification is released, the 3 companies will have certified solutions, and like I said, other companies will also start providing certified solutions. The next category is development partners. So we have 2 groups here that I'm showing. RF module suppliers are very critical aspect of adding connectivity, like I said in the beginning, to a device is not a trivial task, and there is a lot of stuff that has to be considered in the design aspect, and there are also a lot of certification things. So with an RF module supplier, you get FCC and Thread certified RF hardware modules that you can plug into your design. And having a Thread certified module gives you the confidence that your overall product will pass Thread certification with no issues. There are a number of vendors within this category that also offer certified turnkey hardware solutions that help complement your design. So let's say you're building a Thread end node like a window sensor, and your company does not create or market a border router. You can work with a module supplier to get a turnkey design from the module supplier and put your name, plastics on the box, and ship it under your portfolio. Other RF module suppliers also provide software and or design services, so you can get the module for them, but if you need additional services of design services of implementing that within your application, they can provide those types of capabilities. Service suppliers, some examples of this are companies that can provide software stacks or do software stack development if you want to have a custom implementation of Thread. System integrators, so integrating all the different networking and application layer technologies together. manufacturing, hardware design, and network testing to make sure that you're ready for going through certification. And then the last category I want to talk about is OEM product vendors. So the product vendors within Thread Group represent many different markets and applications. And this is a benefit to you because if you want your device to work with other OEMs products, you have a way of accessing those companies and getting building those relationships and getting engaged with them early in your product development cycle and their product development cycle so you can go to market with complete solutions. There are companies that might only produce gateways or border routers, and there are companies that might only take to market end nodes. And so by partnering with different OEM vendors, you can create the true Thread solution. And we do try to give you some tools to help you navigate through the Thread ecosystem. As a non-member, you can go to the publicthreadgroup.org website and look under the Who Are Our Members section, and you can search for specific categories within industry, segment, region, and their membership level. If you become a member of Thread, you get access to the Thread member portal, and you can join the various committees and work with other companies that are also participating in the committees, and you as a member can also attend the all-member meetings, which are held 3 times a year, and have working breakout sessions and networking reception opportunities. What is membership to Thread consist of? There are 3 different categories. The affiliate level is the entry level at $2,500 a year, and this is really intended for companies that either want to join and just learn about Thread. They haven't decided yet on how they want to implement it in their products, but it gives, as an affiliate member, you get access to the documentation and participating in parts of the all member meetings, and you get the communication. So you get more information and you're able to network with other Thread Group members at the affiliate level. The other category of companies at the affiliate level are companies that provide services and are not planning to do an actual Thread certified product, but might have software development, manufacturing, design services that they can provide. The contributor level is the main category, and this is $15,000 a year as a contributor. What the extra benefits you get from that is that the main thing is you have access to the certification program. All products that are taken to market as a Thread solution must be certified. So as a contributor, that gives you access to that. And Thread Group has also worked extremely hard to make certification as simple as possible and provide tools to help companies go through it. We have a test harness, test bed, and a reference commissioning app that we provide to contributor level. Also at the contributor level, you can participate in committees and even chair some of the committees and vote in the committees. So you get access to being able to drive the Thread direction forward. And then the sponsor level is at $100,000 a year, and that is a board level position, and there are limited seats for that, and there's a process to follow if you're interested in the sponsor level that we can, I'm going to, through the Thread Group help desk, you can get inputs on that. We do recognize that in this industry, in the IoT industry, there is quite a bit of innovation happening in startup companies. So companies that didn't exist 1 or 2 years ago are the ones that are creating some really innovative and interesting products in this space, and many of these companies do not have the resources to be able to pay membership fees. So we have an Innovation Enabler Award that we give once a quarter. We want to be able to support these companies. So with this award, there's an application process through our website. It's a very simple process, filling out a form and providing a 2-minute video that's something taken on your iPhone or your phone, just of you talking about what your company does and why you are interested in Thread, what you would want to do with Thread. And the winner every quarter gets a 1-year contributor membership to Thread. So this is really exciting. We've had great success so far with the companies that have one. They're doing really exciting things and have been very active members of Thread group, contributing their ideas and helping us take Thread to the market. And I mentioned this earlier, but it is extremely critical piece of Thread is that certification is required. And the reason for this is we want to make sure that if a product is a Thread product, that it implements the technology properly so that all the devices that are Thread devices connect with no issues. The certification tests for things like commissioning, network functionality, and interoperability. And we offer a certification logo for two different things. One is for an end product, and we offer a separate logo for a component certification. So any like module vendors or chip vendors that have components will have the Thread certified component logo, and that makes it, we do that so it makes it really easy for you to navigate through the ecosystem available when you're looking at what you want to help you build your product. You can look at the stuff that's listed under certified components. Our certification program is in early access mode today, and you'll be hearing more about release of certification in the coming months, and we're really excited about the pipeline that we already have of products that will come to market as Thread products. And I encourage all of you to connect with us. Through our website, you already might be on our email distribution list, but we do have an email distribution list and we send out a quarterly newsletter. We also have a blog on our website. This is fairly new, probably kicked off about 2.5 months ago. Already had several blogs on different topics. We're on LinkedIn, so please connect with us on LinkedIn so you can get updates especially about the all-member meetings, about the blogs when we have them updated. We will share that on through LinkedIn. And then follow us on Twitter so you can get all the latest information. We do a lot of tracking of what's happening in the industry and sharing that through our Twitter handle. So I encourage you guys to please look through all this, use all these resources to help you learn more about Thread and become a member of Thread. If you have any questions as you're going through it, there is a help desk. You can send an email to help@threadgroup.org. I want to thank all of you for your time. We're really excited to host this webinar and the interest that we saw with it. So I will open it now. We have about 15 minutes left in the webinar, and we are going to address the questions, and as Shannon mentioned in the beginning, we will go through the list and answer what we can, and if we run out of time or can't get to all of the questions, we will follow up directly with the person that asked the question. All right, so I guess we have a few questions. Grant, do you want to take the first one?
Happy to, Sujata. Thank you. So the first question that we have has come up. Somebody in the audience asked, why invent Thread while Zigbee has been able to do very similar things? That's actually an excellent question. Zigbee is, in fact, very compelling on a number of different fronts, and part of the strength of Zigbee is its application layer, and that was one reason why the liaison between the Thread group and the Zigbee Alliance makes a lot of sense to bring their application layer to Thread. But from a core networking technology, Zigbee had a couple of attributes that we felt were a bit short of the requirements that we had. One of those was this notion of end-to-end internet addressing and routability. While it's true that there are certainly hardware-specific gateway solutions that allow you to bridge Zigbee applications onto the internet, into the cloud, into mobile devices, fundamentally that represents an investment in an additional piece of hardware, an additional protocol adapter. It becomes an additional point of failure. And so end-to-end addressing was one key piece of that. As we just talked about with that dedicated piece of hardware, that introduces another single point of failure element that we really didn't want or wanted to avoid in the thread architecture and the ideal architecture that we were seeking. Another element of Zigbee is this notion of the security coordinator, which again represents another single point of failure in the architecture that we weren't comfortable with. And then finally, if you look at, say, something like Zigbee IP, which was certainly an IP-based solution for Zigbee, what we found in evaluating that as a technology is there were some fundamental scalability limitations that we found when trying to grow that technology over a handful of tens to nodes that we really wanted to address, and that thread, in fact, does address, where we can see it easily scale up to hundreds of nodes. Hopefully that answers the question.
All right, so let's move to another question. I see a question about what about security aspects. Grant, do you want to take that one?
Happy to. So Thread really incorporates security as a key requirement from the get-go. There are two aspects that we really wanted to make sure were adopted when we were architecting Thread. And the first of those was that from a security perspective, we wanted to employ architectures that leverage defense in depth, and that is security at many different layers of the stack. And so unlike some other different existing legacy home connectivity solutions, we wanted network layer security in Thread to be the default. And so because of that, AES 128-bit link level encryption is on by default in Thread. There is no way to disable it. Thread networks are always secure. The second point is that one of the other key kind of bastions of security in a network is getting devices on and off the network. And traditionally, where we've seen in home connectivity solutions are pairing or commissioning solutions that are very easy to use, but in many cases they're not secure. They either rely on sort of brief windows of time or non-dense networks in which you can assume that there isn't any malicious attacker, or there might not be any neighbors trying to get their devices on the network. Kind of the Christmas morning problem in which you have a neighbor on the other side of the wall in high-density housing that might be pairing a device at the same time. All that to say, we designed Thread's commissioning and out-of-box experience protocol to be definitionally secure, in that the only way you can get a Thread device onto a Thread network is that you physically have it in your hand, and it's absolutely the device that you intend to be pairing and commissioning, not the one that your neighbor intends to be commissioning or pairing, or the one that a malicious attacker attempting to do a man-in-the-middle attack is attempting to convince you to pair. And so beyond that, then Thread gives you kind of that basic groundwork to then build secure applications on top of that. And of course, it's always a good idea to use and secure session layers on top of Thread. But if you so choose, Thread again provides a great secure substrate to build on top of directly.
Great, Grant. Thank you. I see another question here. Can a chip that supports Zigbee be reprogrammed to run a Thread stack? So the answer is theoretically yes. The radio functionality itself is all that Thread needs. You would have to look at the other resources on the chip that's being used to ensure that the memory requirements are able to support Thread. But Thread and Zigbee, being both 15.4 stack solutions, have very similar memory requirements. So that is an advantage with Thread. That is why we wanted Thread to be built on existing solutions where possible. We really want to be able to bring products to market quickly and leverage the expertise and proven technologies that are already available in the market. And I think you can look at products that have run Zigbee today. They can be reprogrammed to run Thread.
So one of the next questions that was asked was, when is Thread over BLE, Wi-Fi, and LTE expected? It's important to remember in these particular examples, you don't really necessarily need Thread to be able to provide end-to-end connectivity solutions for those particular technologies. Let's take Wi-Fi, for example. There's already a very well-defined adaptation of transporting both IPv4 and IPv6 natively over Wi-Fi networks with no additional protocols necessary. Therefore, Thread and Wi-Fi are really great complementary technologies in which Thread is typically your connectivity for low power, low bandwidth devices within the home. And then typically you have a device in the Thread architecture called a border router, which allows Thread IPv6 traffic to be bridged onto or routed onto the Wi-Fi network at the IP layer and then moved onto Wi-Fi and, if necessary, off into the greater cloud at large. In terms of LTE, very similar. The cellular providers and the GSM stack providers have really already provided a well-defined IPv6 bearer or adaptation for data carrying over LTE or. And from that perspective, again, you just need simply a border router that knows how to route IPv6 traffic from a Thread network onto an LTE network or any other kind of cellular network. And again, therefore, you've got easy end-to-end IPv6 connectivity. In terms of BLE, there's actually right now a number of different IETF drafts that are proposing to adapt 6LoWPAN to Bluetooth low energy networks in a variety of different ways. And from that perspective, using one of those RFC drafts defining our 6LoWPAN over BLE, you could also easily then just apply IPv6 routing semantics to transition Thread traffic onto and off of BLE networks as well.
Okay, and then I see another question here. Can a Thread-enabled contact sensor connect to the internet directly without a border router? And I don't know, Grant, if you want to supplement it, but okay.
Happy to take that one. So fundamentally, if you are in a situation in which the end cloud service that you would like to talk to from the Thread device is IPv6 enabled, and there's a way to transition that Thread traffic directly onto the cloud, sure, in theory that you could do it without a border router, but fundamentally to get to the cloud you either need a Wi-Fi gateway, an Ethernet gateway, or a cellular gateway, and at that point really all you're doing is forwarding IPv6 traffic in an IP routing sense from one network interface to another without any intervening NAT or Teredo tunnels or those types of things, and it's absolutely an application that Thread envisioned from the get-go and is absolutely something that you should be able to accomplish. But again, you will probably need a border router just to get off the Thread network onto some other particular medium, unless again your cloud was somehow directly connected over Thread, unlikely as that may be.
Great. Another question is about the documentation. So there are white papers that are available publicly. You can download from the Thread Group website, which is threadgroup.org. The actual specification is available to members only. Another question here is, what's the difference between home automation and connected home? To me, home automation is a part of connected home. So home automation is about like controlling blinds, unlocking doors, controlling fans, whereas other applications within the connected home could be appliances and thermostats.
So one of the next questions is, are there interoperability test houses for each of the application layer standards similar to iControl for Zigbee? At this point, there is one test house defined for Thread testing, and that is UL Labs. They will be executing the official Thread certification program when it gets up to speed and is released at scale. Over time, I think it's certainly reasonable and likely that you will find particular test houses, among them possibly UL, that will be specialized in interoperability testing and sort of application layer testing for each of the application layers. But that will, of course, be subject to the test of time as application layers for Thread roll out, or as application layers migrate and port themselves over to, or at least claim interoperability or interwork with Thread.
Okay, and then this question I can take very easily. What about Freescale? So Nxp and Freescale merged back in December 2015, so just a few months ago. And yes, Freescale was the founding member of Thread, but after the merger we are now Nxp, and same product, same chip, same silicon is all there, just a different name. The other question I see here is about Zigbee. Is Zigbee 3.0 have both Zigbee Pro connectivity layer and thread layer? So with Zigbee 3.0 you have the option, if you want Zigbee Pro, then you use that, or you can have the IP-based solution would be thread. There's another question here about, are there any real-world stories or examples that can be discussed publicly about systems successfully scaling to 250 plus nodes per system? Since certification is not released and there are not end products in the market, we cannot talk about that, but I can say that as a NXP and having a stack on silicon, it has been tested in greater than 250 node network environment and runs fine.
So one of the next questions is, what application protocol is used for Thread certification? Thread certification really focuses on network layer conformance as well as network layer interoperability, and commissioning conformance and commissioning interoperability. From that perspective, commissioning is sort of an application level protocol in and of itself, in that it uses UDP and rides on top of IPv6. The only other sort of application layer testing that is done as part of the certification suite is ensuring that end-to-end ICMP, echo request, echo reply traffic works correctly. And that, of course, is neither UDP nor TCP, but just ICMP traffic over IPv6. But those are really the only application layer bits of functionality that get exercised as part of the Thread conformance and interoperability suite. One of the final questions I think we'll have time for is, how are lost paths handled? I think the answer there, if UDP, then up to top layer. Generally speaking, TCP is not an ideal choice for the Thread network because latency to TCP due to sleepy end nodes fundamentally looks like congestion. And so from that perspective, applications that are best suited for Thread are UDP based. And certainly many of the app layers work well over UDP networks and have app layer acknowledgement and retry. And from that perspective, the person that answered the question is correct, that it really is left up to the app layer. And final question, what is the process for commissioning Thread-enabled devices? Very briefly, since we are nearly out of time, basically each Thread device that's produced has a unique pairing code that's created at the time of manufacture. And the idea is that there is a user end device, whether it's a mobile phone, a personal computer, or what have you, that physically has the device in their hand, looks at and enters that pairing code onto the device. That pairing code is then entered into an algorithm, cryptographic algorithm called JPEG, which key stretches that pairing code into a longer session key that then is used to establish a session between the joining device and the mobile device, which is a commissioner. And then over that secure channel, the pairing traffic or the commissioning traffic occurs to securely provision the joining device with all of the key material that the device will need to join and participate over the lifetime of that device on the Thread network. but it's designed to be a very user-friendly, very simple out-of-box process.
Great. Well, those were really great questions. Again, Grant and I want to thank you for your time and remind you that the webinar is recorded and we'll post it on the website in the coming days, and we'll also email to everyone who was registered. And for the questions that we were not able to cover in the allotted time, we will follow up separately on that. So thank you, everybody, and have a great day.